Let's explore some modules in Python. Modules are programs that we can import into our own program, accessing other things that have been written that aren't necessarily part of Python directly, but that we can access and use as if they were. We can write our own modules. We will do that later in the term. But a couple of modules that we want to explore bits and pieces of, the random module and then the math module. So the random module gives us a way to mimic randomness. The term random has a very specific and technical meaning, and actually what the random module in Python gives us is a pseudo-random approach. We won't get into the technical details now. We will mention some things again a little bit later in the term about randomness, but that's kind of an aside from where we are right now. So for our purposes, the random module will let us create things that at least appear to us to be random. So to use the random module in your program, we will import random. There are lots of methods in the random module. So sometimes we want to import specific things, but we want to be able to access all of them right now. So we will just import random. And so if we want to see something from the random module, we can first of all think of just getting a random number. So we could say something like x equals, since we're importing things from the random module, we use the dot notation. So say x equals random dot, and one of the basic pieces of the random module is a method called random. If we say x equal random dot random, what we're doing is creating a random number, pseudo-random, but we're going to continue to say random, a random number, and assigning that to the value x. Now the random number that we're creating is in the interval 0 to 1, including 0, but not including 1. So sometimes we'll use this value to represent, say, the probability of something, because a probability is a number between 0 and 1. Probability can be 1, but that is something that's guaranteed to happen. Otherwise, the probability is something between 0 and 1. If something will not happen, its probability is 0. If it's guaranteed to happen, the probability is 1. In between, you will have things that may or may not happen. We often think of probabilities in terms of percentages, percent chance of something happening, but we can write that as just a number between 0 and 1. So in this particular case, if you type in this and hit enter, if you're in the interactive shell, you will get a number. It will be a different number maybe than I will get or someone else, depending on the way random works depends on some different factors, which we're not going to go into right now. So one aspect of the random module is being able to create individual random numbers between 0 and 1. But if you want a number that's not between 0 and 1, but you still need a random number, there is another method called uniform, and it also requires input. But here we can put in numbers a and b. So for instance, if we wanted numbers between 2.1 and 2.7, uniform from 2.1 to 2.7 will give us values in that interval between 2.1 and 2.7. And so all of the random values in that case, instead of being in the interval 0 to 1, would be in this new interval. Sometimes instead of just numbers like this, we want particular integers. So instead of using random or uniform, there's another possibility of rand_int. In rand_int, we put in an integer a, we put in an integer b. We have to put particular values in there. So let's say we go from 3 to 10. Rand_int from 3 to 10 will be a random integer n, with, in this case, 3 will be less than or equal to, it will be less than or equal to 10. So we will get a number that's between the endpoints, but possibly including 3 or 10 in this case. Rand_int, you can have big intervals, big ranges there, and it would just pick an appropriate random, again, a pseudo-random choice between 3 and 10. You can use any numbers you want for A and B in terms of the endpoints for the interval. Okay, there are several other possibilities with the random module. And so we're going to look at a couple of options here. If we had, say, a list, we had a list of card values. These 2, 3, 4, 5, we can go all the way through all the card values if we wanted. Another built-in method in the random module is shuffle. So we could do random.shuffle and shuffle the list T, and this will give us a rearrangement. Shuffle will do what you expect. It will shuffle those values. It will make a change to the list T, and you get a new list if you shuffle. So if you want to keep the original list and have a new shuffled value that's separate, then you would assign this to a variable. So we could say something else, give it a name, and assign that to shuffle. So random.shuffle T, but assign that to a variable. If we don't do that, we've made the change to the list T. So in other words, if we don't want to change the list T and we're using shuffle, then we want to make a copy of T before we do that and shuffle the copy, because otherwise we're going to affect T and change it. Okay, so we want to keep the original, shuffle a copy, don't shuffle the actual original. All right, so shuffle will just move things around. There is a method choice that will allow us to select things, or select one thing from the list. So we could assign variable selection, and random.choice from T, and this would select one of the values and assign it to the variable selection. There's also another method called choices, plural, and that will, you tell how many things you want to select, and it will select that many things from the list, but each time it will put them back. So it'll take something out, give you the value, put that value back in, and be able to select. So you might be able to select 3 aces and a 2 if you were selecting, say, 4 things from our list. So choices is selection with replacement. Sometimes, though, we want to select things and not put them back. So if we select things and don't put them back, the method in this case is sample. So if we were to use sample, in sample, we give the population that we're talking about. So in our case, we have the list T, and then we can tell how many things that we want to select. Let's say we decide to select 3 of them. So in this case, selected set would pick 3 things from amongst the 5, but when it takes one out, it won't reselect that value. So if it chooses ace, then it's only going to choose ace 1 time. Again, there's a lot of things you can do with these, creating other sets and other scenarios, but we can create random samples. We can create basically a random selection of something, an integer, a value, or a number between some given ranges. And so we're going to use this random module to create a rock, paper, scissors game. Okay, so the idea here is let's create rock, paper, scissors. In our rock, paper, scissors, we're going to create a function. No inputs. We're just going to run the game. And so we have the option in rock, paper, scissors are rock, paper, and scissors. Before we've created our function, to the left here we had said import random, but I'm going to include it in case we were writing this in a new separate file. We'll import random so that we can use that. So inside our function, we want to create player A's choice, and we're going to do this as a random selection. So we're going to create a version of rock, paper, scissors that we don't participate in. We could set it up so that we make one choice and let the computer make the other choice. But right now, we're just going to have the computer making both choices. And so for player A, we will have player A make a random choice. And then we will have player B make a random choice. All right, so at this point, what happens? A is assigned a value from rock, paper, or scissors, and then B is assigned a value from rock, paper, or scissors. They could get the same value, or they could get different values. So what's going to happen if they choose the same value, then we're going to create we're going to say this was a tie game, and then otherwise we will go through all the scenarios to see who actually won the game. Okay, so if A is equal to B, then we will have some result of a tie game. But what happens if A is not equal to B? If A is not equal to B, then we need to consider some other possibilities. So if A is not equal to B, then the other possibilities, we will go through each one of those and determine who actually won the game. All right, so what's going to happen here if it wasn't a tie, then there are two possibilities. So I'm just going to write down these possibilities in a list. Two possibilities are that player A wins or that player B wins. So let's work through these options then. Let's only write down the possibilities or modify the possibilities in case of a player A win. So if start with the assumption that player A wins the game and only modify that if player B actually came back to win. All right, so what's going to happen? If player A has chosen rock, then what's going to happen? Well, since we're in the else situation, we know that player B did not choose rock. So if player B chooses scissors, then player A wins, and we've already recorded the result of player A wins. So let's only look at what happens if player B chooses paper. If player B chooses paper, then we're going to change the result. And the result would be entry possibilities 1. Okay, so earlier when I set result equals player A wins, we could have said possibilities 0. Back here, and what's the idea then? If we decide to change what the possibilities are, we could do that one time in the list here and not have to change it multiple times. Okay, so what do we have so far? If A and B are the same, we get a tie game. Otherwise, we have situations where player A is going to win or player B is going to win. If A plays rock and B plays paper, then player B wins. But otherwise, if player B plays scissors, then A wins. So we're not going to look at that specifically. We've already kind of covered that scenario. All right, so what's left? We then have to look at the other situations of what happens if A plays one of the other possibilities. All right, so we would have an L if A is paper. And then we could consider, all right, what situation will B win? B can't be paper because we're not in the tie game situation. The way for B to win would be if B played scissors. So at this point, if B is scissors, then we set the result again to be possibilities 1, change it away from player A wins to make it player B wins. And then one more condition would be the else, or we could say L if A is scissors, and only change that if B is rock. And so then at the end of this, we would want to return maybe the values A, B, and result. We put those into a list and return those values. So try that, and then what would happen to play the game, we could have something like clear a bit of this. So once we have all of the pieces of the game in place, basically the situation for if A is paper, changing the winner to player B, and if A plays scissors, the situation when player B wins. We could then run the program and do something like game equals RPS. And so in this situation, I said, let's have the function return a list. So we would have a line down here in the function after we finish the other else, the elif and the else statement. We could do something like return A, B, and result. And so when we call game equal RPS, then what that would do is the game would get a value A, B, and result. There'd be a list. And so then we could do something like this. We could say print player A chose the value that's going to come from game, which would be the 0th position, right? The first position. And player B goes down here below just to keep to show it all, but you would keep typing on the same line. And so what happens, we would get these values for who won, what player A chose, what player B chose, and what happened at the end of the game. And that would come from the function, and the function would have gotten its values as a result of applying pieces from the random module. So try that out. Fill in the missing pieces. There are missing pieces over here. From the choices, once we've looked at paper and what we will look at when A chooses scissors. So explore with that and see what you can come up with. See if you can get this to work correctly for player A choosing something, player B choosing something, and then getting the correct winner of the game.